So we're going to talk about radian measure. Before we do that, let's talk a bit more about pi. Recall that for a circle, that the circumference is equal to pi times the diameter, where the diameter is a chord that goes through the center of a circle. So here is the diameter of this circle. If you take the equation of circumference and divide both sides by the diameter, you get that pi is equal to the circumference divided by the diameter. What does that mean? This tells you that there are pi diameters around the circle. So here's one of them, here's the second, here's the third, and then this distance here is approximately equal to 0.14159 of a diameter. So there are pi diameters around a circle. So how many radii wrap around a circle? Well, if they're pi diameters, then there must be 2 pi radii that wrap around a circle. Since there are 2 radii for every diameter, that means there must be 2 pi radii around a circle. So what about half a circle? Well, for half a circle, there must be half the number of radii. So that would be pi radii wrap around half a circle. So if we were to take our picture here, draw our diameter, noting that half a diameter is a radii, or radius. So there would be 1, 2, 3 radii plus 0.14159 of a radius. So there'd be pi of these radiuses going around half a circle. So now let's talk about a radian. The angle that is created by an arc length r is called a radian. So what we're saying is that if you take the radius of this circle and wrap it around the outside of this circle, so here's the length of one radius on the outside, that the angle that you have traveled, theta, is equal to 1 radian. So again, in a circle, there would be 2 pi of these radians. And in half a circle, there'd be pi radians. So what does this mean about a radian? For half a circle, pi radians is equivalent to 180 degrees. You traveled halfway around a circle. And for a full circle, since that's 2 pi radians, that's equivalent to 360 degrees. So what is the measure in degrees of 1 radian? So we know that 180 degrees is equivalent to pi radians. So using your calculator, you can show there's approximately 57.3 degrees per radian. So let's talk a bit more about radians. Let's go to our first example. So a point is rotated around a circle. Its start and finish is shown. State the rotation in radian measure. So notice in our first diagram, we've traveled 1/3 of the way around the circle. I split the circle into 3 parts. So we've traveled 1/3 of the way around the circle in a counterclockwise rotation. A full circle has 2 pi radians, so 1/3 of 2 pi is 2 pi over 3 radians, which is equivalent to 120 degrees. 360 divided by 3. So this circle's split into 8 equal parts. We've traveled 3 out of the 8 parts. It's going in a clockwise rotation, so that means that we're going to have a negative angle this time, and a full circle is 2 pi radians. This would give us negative 6 pi over 8, which is equivalent to negative 3 pi over 4. And in terms of degrees, that would be minus 135 degrees. And for our last circle, we're moving 1/4 of the way around the circle in a positive rotation. A full circle has 2 pi radians, so 2 pi over 4 is equivalent to pi over 2 radians, which is equivalent to 90 degrees. So let's convert each of the following to radians. So 45 degrees, if we use the fact that pi radians is equivalent to 180 degrees. Notice the degrees in the numerator and denominator will cancel and leave you with radians. So we have 45 pi over 180 radians, which is equivalent to pi over 4 radians. Same thing with the next one. We can multiply by pi over 180, and that gives us 225 pi over 180, which again we can reduce down to 5 pi over 4 radians. And the final one, we multiply by pi over 180, and we end up with 315 pi over 180 degrees, which reduces down to 7 pi over 4 radians. Convert each of the following angles to degrees. So we're just going to multiply by the reciprocal ratio. So we're going to multiply by 180 degrees over pi this time. So we see the degrees is in the numerator, so therefore we'll end up with degrees as our solution. We see that the pi's will cancel. Also note that 6 goes into 180 30 times. And we are left with 5 times 30, which is 150 degrees. Let's try it again. So we multiply by 180 degrees over pi. Pi's will cancel. And 180 divided by 3 gives us 60 degrees. And for the final one, so we take 2.5, multiply it by 180 divided by pi. And that gives us 450 divided by pi, which if you use your calculator will give you 143.2 degrees. And our last example. Determine the arc length of a circle with a radius of 12 centimeters if the central angle is 5 radians. So here's our radius. And we know we have a radius of 12. And we're going to travel 5 radians inside this circle, and I want to know what is the arc length, so what distance did we travel around the circle. With radians, it's much easier to determine your arc length. Remember that 1 radian is equivalent to traveling 1 radius. So if we've traveled 5 radians, we've traveled 5 radiuses around the circle. So all we have to do is take 5 times 12, and that tells us that we've traveled 60 centimeters around the circle. Now let's look at 205 degrees. So let's say this is 205 degrees, and I want to find the distance we travel around the circle. There's a few more calculations we need to make. First of all, we need to note that the circumference of the circle is 2 pi times the radius, which is 24 pi. Well, how far did we travel around the circle? We can note that we've traveled 205 degrees out of the possible 360 degrees, and that'll give us our arc length if we multiply it by the circumference, which in this example will give us 41 pi over 3 centimeters, or using our calculator, 42.9 centimeters. And again, this is the percentage of the circumference we've traveled. 205 out of the possible 360 degrees. Then multiplied by the full circumference of the circle, 24 pi. So this is just an introduction to radians. We'll talk more about them in the next video.